Hello, welcome back to your new term of maths. In this term, the first thing we're going to be studying is decimals. So I'd like you to start off this morning by just having a look at these questions and answering them as quickly as you can, and then getting ready to move on. Pause the lesson now and restart it when you've finished. Okay, so let's have a look at these first questions. Obviously, the first one I don't have to write anything down. Question 1, the first number is 7,602,385. The second number is 17,400,039. Remember that the numbers occur in groups of 3, and in each group of 3 there is 1,000, 100, and a 1. So you can use those to build up the numbers. Question 2. What is the value of the 7 in these numbers? Well, the first number, the 7, is the first place after the decimals. So that would be a tenth. In the second number, the number is in the second place after the decimals. So that would be a hundredth. And the final number, the 7, is in the third place after the decimals, so that would be a thousandth. You must have those THs on the end. What are the numbers in part A written in are the numbers in part A written in ascending order, descending order, or neither? Right, okay, so let's have a look at them. The first number, the ones number in each case, is a 5, so that doesn't help us. The next number over, the tenths, because remember this is how we do it. We start on the furthest left of the number and work our way across. The next number, the tenths, we have a 7, a 9, and then an 8. Well, 7, 9, 8 is not in an order. So the answer to part B is no order, because they're neither in ascending order nor descending order. They're sort of higgledy-piggledy. And C, round the numbers in part A to 1 decimal place. Well, I'm going to write this one out in full, and because rounding obviously is something that's really important. So for my first number, I had 5.731. If I round it to 1 decimal place, I'm rounding it to the first number after the decimal point, which is a 7. The next number is a 3. That means that I'm trying to now decide, is this number closer to 5.7 or 5.8? Well, 3 is less than 5, so we round down. So that number becomes 5.7 to 1 decimal place. My next number, 5.97 to 1 decimal place. Right, so I look at so I've got 5.9, I look at my next number, it's a 7, that means I've got to round up. Well, the number that's 1 more than 9 is 10. So I've got to actually round up again, so that number becomes 6.0 to 1 decimal place. You must write that 0 down. The 0 tells you something. It tells you what that number could be, the range that number could be. So in this case, if you're told to write to 1 decimal place, even if the number is a 0, you must write it down. So 6.0. And lastly, we have 5.827. So 5.8, 1 decimal place. Then I look at the next number, it's a 2, so I ignore it. So my number stays as 5.8 to 1 decimal place. Always write it after when you round what you rounded it to, so people can see what you're doing. Question 3. What is the place value of the first non-zero digit in these numbers. So the first number that isn't a 0. On the first number in the first one, we've got 0.3, so my first number is in the first place of decimals. So that is a tenth. When I look at my next number, it's the third place of decimals. So that is a thousandth. And lastly, the first non-zero number is in the second place of decimals, so that is a hundredth. Okay, if you need to write any corrections, pause the lesson and rejoin when you're ready. So the next thing we're going to look at here is a key point, which I think is a pretty good idea for you to write down in this case. A number rounded to 2 decimal places has 2 digits after the decimal point. A number rounded to 3 decimal places has 3 digits after the decimal point. So pause the tape, please, write that down, and when you've finished, restart the lesson. Okay, so for this next one, I'm gonna just go through these really quickly because they all make pretty much sense. If I start on the left and work my way across, 7.63 has 2 decimal places, so 2 dp. 12.041, the next one, has 3 decimal places, 3 dp. 37.3 has 1 decimal place. 4.011 has 3 decimal places. 14.72 has 2 decimal places. And 9.00 has 2 decimal places. I hope that is understandable. So let's move on to the next one. And here we have a quick diagram of rounding. For rounding to 2 decimal places, look at the thousandths, the third decimal place, the third number. If it's 5 or more, you round up, you add 1 to the tenths. If it's 4 or less, you round down, so you ignore it. So if we look at that diagram, that number line, we can see that exactly between 2.17 and 2.18 is 2.175. If it's less than 2.175, it will be closer to 2.17. If it's 2.175 or more, it will be closer to 2.18. So we round up. Remember, when we're rounding, we're either going to ignore or add 1, nothing else, to the final number. So now we come to a little bit of work for yourselves. Question 5. Round each number to 2 decimal places. So pause the lesson, answer the questions, restart the lesson when you're ready to carry on. So working my way through this one, A, 2.176. I'm looking to 2 decimal places, so I'm looking at the 6. The 6 obviously is more than 5, so I add 1 to this, so this becomes 2.18 to 2 decimal places. B, 489. Obviously with the 9 I'm going to add 1 to the 8, so that's going to become 7. I'm sorry, I've written down that wrong. 7.4. Yes, no, I haven't. 89. My mistake, I haven't. So that becomes 7.49 to 2 decimal places. C, 5.083. I'm looking at the 3, it's less than 5, so I ignore it. 5.08 to decimal places. D, 6.199. Now this is the sort of question that you're always going to be asked. I look at the next number, so this is a 9, so I'm going to add 1 onto this. If I add 1 to 9, I get 10, so obviously I have to write down a note and carry another one. So the number, I'm going to have to change both of these numbers. So this becomes 6.20 to DP. Once again, even though it's ending on a 0, because we're rounding, we have to add that 0 in. E, 45.157. So looking at the 7, 7 means we're going to be rounding it up, so that becomes 45.16. Places. F, 23.007 becomes, well, I'm looking at the 7 to decide if I'm going to round up or down. I'm going to round up, so I'm going to add 1 to this, so this number becomes 23.01 to 2 decimal places. G, 0.8631. So 2 decimal places means I'm looking at the 3, the third decimal place, 3, I round down, so that becomes 0.86 to 2 decimal places. And lastly, H, 9.002 becomes, well, it's a 2, so I round it down, 9.00 to 2 decimal places. So those are my answers for those questions. If you need to pause the lesson now to check your corrections, please do so, and then rejoin when you're ready. So just as a reminder, really, if we're rounding to 3 decimal places, we're going to look at the 4th number, the 10,000ths, to determine whether we round up or down. So in all cases, whenever we're rounding, we look at the next. If we're rounding to 3 decimal places, we look at the 4th number. If we're rounding to 7 decimal places, we look at the 8th number. The pattern doesn't change. So this is just a quick reminder. The whole process works exactly the same apart from that. Okay, the one nice thing about rounding questions is that we can sometimes use the same set of questions and get two different answers. So for these set of questions, I would like you to first off round each set of numbers to 2 decimal places, and then round each set of numbers to 3 decimal places. So you get effectively double value out of this set of questions. So pause the lesson and restart after you've completed. Thank you. Okay, I'm going to go through these questions a little quicker now because we've done effectively all of them once, so we should be able now really to go through it quite quickly. So this is set 1, so this is going to be to 2 decimal places. A is 8.93. B is 69.09. C is 72.76. D is 3.26. E is 85.81. F is 29.80. G is 5.09. And H is 34.06. So all of those numbers are rounded to 2 decimal places. As well as that, we have set 2, which are the same numbers, but we're going to round them to 3 decimal places. So A is 8.932, B is 69.085, C is 72.756, D is 3.257, E is 85.801, F, 807, my mistake, F is 29.797, G is 5.087, and H is 34.061. Okay, if you need to pause the tape there to check any corrections, please do so. Otherwise, we will carry on in a second. In a restaurant, the tips are divided equally between the workers. One evening, the tips total £8.55, and there are 6 workers. The manager uses a calculator to work out how much each worker receives, and he gets that answer: £9 and 9.1666666667. How much should each worker receive? Did you round up or down? Explain. Okay, so pause the tape, please, and answer this question. Okay, so here we've got a number, but we have a slight problem because here we're going to divide up money. Obviously £9 is not a problem, we can do £16, but we now have that rest of the money. Obviously we can't give someone 0.6 of a penny, so we're not going to do that. But we can't actually give them all. We can't round it up and say, okay, we're going to give them all £9.17. Well, we can't give them all £9.17, which we should do. According to this, we should round up to £9.17, but we can't, because if we do that, we won't have enough money. We haven't got that. So in this case, the amount of money that we've got to give is £9.16, because there is not enough. Because there is not enough. Which means I believe that the owner of the restaurant will be left with 2p. So it's not a huge problem really. Okay, if that's not what you had written down, please write it down now, have a good think about it, make certain that you understand exactly why I've done what I've done. For most calculations, an approximate degree of accuracy is a value you can measure easily and accurately. For example, you can easily and accurately measure 6.1 centimeters, but not 6.075 centimeters. Okay, what I would like you to do is actually write that down, because I think that's a really important fact. You must understand what they mean by an appropriate degree of accuracy. So pause the lesson and restart when you've finished. Right, now I'd like to move on to a question on that. Work out the length of one side of a square with a perimeter of those measurements. Round your answers to an appropriate degree of accuracy. Pause the lesson and restart after you've answered your work. Just to sort of clarify and make things a bit easier, I've just put a ruler on the visualizer for a second, just to help you sort of get a grip of what we're talking about here. If I was measuring in centimeters, I can very easily measure in centimeters. I can very easily measure in these smaller measurements as well, which are millimeters, tenths of meters, so the first decimal place. If I try to go beyond that and try to measure tenths between those two lines there, which as you can see is exactly the width of my pen, it would be very difficult. So sort of trying to measure beyond one place of decimals when you're talking about centimetres is perhaps, it's too accurate. You cannot actually measure anything much finer than that. So please bear that one in mind when we're answering these questions. Okay, let me just pan back out, make that nice and easy to see, and then we'll go through these questions. So obviously the first question, we have work out the length of one side of the square. Now obviously to work out the length of one side of a square from a perimeter, we just divide the perimeter by 4, because a square has 4 sides, each side is the same length. So 10, so we'll call this one A, 10 divided by 4 equals 2.5 centimetres. And that's fine. We can definitely measure 2.5. It's all there, it's marked out on our ruler. That's easy. B. We've got 24.3, which if we use it, and we need again to divide that by 4, if we do that, we get 6.075. Very, very difficult to measure. So I'm going to round this to 1 decimal place. So that will become 6.1 centimetres, 1 decimal place. That's a suitable degree of accuracy for this. It's not 100% accurate, but it's close enough. And then the last one, 13.65, which if I divide that by 4, I get 3.4125. Once again, 1 decimal place, 3.4 centimetres, 1 decimal place. I hope the ruler helps to understand what we're talking about when we're talking about in degrees of accuracy. It's a concept that you're going to meet quite regularly in maths, and especially science, as you progress. So it's very important we understand exactly what it means now. Okay, so those weren't the figures that you get. Stop now and rejoin when you're ready. Another key point. To save writing all the zeros, you can write very large numbers as a decimal number, in this case of millions. For example, you can write 2,500,000 as 2.5 million. So what we've actually done is we've just said, okay, let's assume in the space between the millions column and the 100,000s column, there is a decimal place. And we just treat the number as that, and we write it in words. It just fills up a little bit less room on the space. It's not as accurate. It's okay in this case, but in some cases there's a degree of rounding. But when we do this, we always round it to 1 decimal place. Don't worry about the 2 point and loads of numbers after it. And just to 1 decimal place, please. So stop the lesson for now, write down that key point please, and then restart when you're ready. Okay. So you've got a question based on that very same topic. We have a list of 10 capital cities in Europe. It's actually a list in descending order. And what the question asks you to do is write each one of those numbers in as a decimal number of millions to 1 decimal place. So when you're ready, pause the lesson and write your table down, and then restart after you've finished. Okay, I'm going to quickly read out the answers. I don't think there's any need to write them down. Just make certain that this is what you've done. So Moscow 11.5 million, London 8.2 million, Berlin 3.5 million, Madrid 3.2 million, Rome 2.8 million, Paris 2.3 million, Budapest 1.7 million, Vienna 1.6 million, Prague 1.2 million, and finally Dublin 1.0 million. You may need to replay that part of the lesson just to make certain that you've got all your corrections written down. And that brings us to the end of this lesson. Next lesson we'll be carrying on with a little bit more of rounding, but this time to significant figures and also some ordering of decimal numbers. Okay, thank you. Bye.